And hello again YouTube, DVD here. Today I'm gonna talk about my flash sensors library. As you can see, this window here of the notepad. You can say, why did you name your library like that? What's the point? Well, I made this thing because I need a little more performance from the E2 rangers, and this thing is actually faster than the default wire expression 2 rangers. You can say why? Well, that's easy. I actually create one ranger at the start of the chip, then I sample it multiple times so I can collect the data. What are actually the arguments? The key, which is a unique key of the sensor constrained to the entity. Second thing is the position, local position where this sensor should be spawned, direction where it looks at, and length, how long actually is it. So you can see here that actually the trace line function does not return anything. I did not put anything here because I've set up my output variable to this local table here. You know that you can store your traces in a table by giving this table as an argument. So why this thing is actually faster? First, you don't create this table many times. It just stores the data right here. And actually, you don't calculate the position and direction and the length every time. This is done once. And based on that, the start and the end position are calculated relative to the entity, of course. I'm using here entity index key, so in one entity you can have as many sensors as you want to, and then I sample the thing and I can get any data I want. This thing is actually 30% faster than the wire rangers. So I'll provide a link in the description for you guys if you want to experiment with my library. This function is actually for test. I use this tracer test to only call the trace to see how many ops does it eat while running. So let's go right now to Gmod, guys, and I'll show you how it works. See you in a minute. So hi guys, me here. Let's see the difference between these algorithms. First I'm gonna show you the E2 chips that are actually quite the same. Here we have only trace that we are performing, nothing else, just the trace. Just calls the trace line function from the Gmod library. It gives 67 ops. Here we have a standard wire expression 2 ranger, which gives 103 ops with CPU time of 200, about roughly. It changes, but oh well. And here we have my new my new flash sensor library. As you see here, I'm sampling the tracer, then getting the data. It gives roughly 77 ops. That's 26 ops less than the standard ranger. See that? Let's say it's roughly about 30 units, because it's easier to to do the math here. If you have 8 rangers like I do, that will be 240 ops for every maglev module that you have, or something else that needs roughly 8 rangers. And if you have more rangers, more traces will have to be performed, and that will slow your code a lot. So guys, that's about it. It works fast. You can see here the debugger list. Oops, that's kind of quite a small thing for you that you can read, so let's put a screen here with 2 values. And made it bigger. There we go. Flash library and the E2 rangers. And my flash library is actually that, and my E2 rangers is that. If I move this, it will trace the thing quite fast, and as this one does, but this thing is actually quite slow, as you saw here. So that's about it, guys. Thank you for watching, and see you next time.